Unit 10, infinite series, and in particular, Unit 10.1 power series. So here we go, jumping into the deep end of the pool. I like the quote I found: mathematics is the alphabet with which God has written the universe, because you're going to see some of that, some weird, crazy relations that connect things like sine and cosine in ways that you never expected before. When I write up what you should be able to do by the end of the chapter, I usually say, well, this one's simple, this one's not too bad. I put tricky, pure evil for all of them. This is infinite series. It's very doable. It takes time and energy. It is a different type of math. A lot of people get very frustrated when they don't get it right away. Well, I hate to put it this way, because there's a lot of other things you can do in life, like teach yourself to play the violin, that are very frustrating, but you'll get them eventually. Well, what's going on here is you're going to learn some really interesting math, but yeah, it's not easy. It's time consuming. So we're going to use a series to represent a function. Sine of x becomes x minus x to the third over 3 factorial plus, like, how is that possible? We're going to learn to differentiate and integrate an infinite series. Like, we only have to do 2 or 3, recognize a pattern, rewrite it, all this stuff, right? You're going to find out what Maclaurin and Taylor are. You're going to learn how to combine Taylor series. You're going to have them approximate a function, calculate an error, and this is where I lose people. So if it's just one item on the list, don't let it make you crazy. And then you dig deep into the weeds in the back half of the unit, where you start saying, does this series converge? Well, yes. Okay, what's it converge to? Well, we don't know. Well, that doesn't help me. So yeah, we're going to be doing a lot of that, and be ready to hit the ground running. So we're going to start with what we call a power series, and it's just a summation. One of the big problems people have here is they get lost on the notation, and they just get very frustrated by it. So just keep at it. You'll be fine. First off, what's the sum of this? Now, we're going to use something called partial sums. And that's very classic in a AP question. Hey, use the concept of partial sums, which means add them up. Well, that's 0.75. We'll add up these. Well, that's 0.875. So we have 0.75, then we get 0.875. And then we keep going. We get I believe it's 9125. Don't hold me to that. I'm just doing this on the fly. And you keep adding, and you keep realizing, man, we're getting closer and closer and closer to 2. And we never actually get there. So can we say it equals 2? Well, here we go. Here's the first step in infinite series. Yes, we can say it equals 2. It converges and it converges. Sorry, trying to get a little better focus here. It converges and it converges to 2. Now, I should have slowed down. We've done sequences, which are just commas. Now we're doing series, where we add them up. That's a very different animal. It's pretty wild. So, for example, the sequence, if this was commas, would go to 0. One of our really massive numbers is 0. We know that. Yeah, well, now we're adding them up. So we don't know. I know this one because it's a geometric series, and I know how that works. But this one is, it actually diverges. And we talked about this a little bit last unit with the integral test, but not enough. So more on that coming along. So a lot of people think of a series just adding numbers up. Hey, add up 1, 2, and 3. Well, this is an infinite series. They never end. To which you say, how can I possibly add them up? Okay, like I said, welcome to series, where things get really weird and confusing. We're going to be able to add up certain series. Worse than that, we're going to be able to say, yep, it adds up. What's it add up to? Well, we don't know that. So here's our notation. This is a summation, and then we'll have anything down here. In this case, we've gone with K. We'll see N a lot of times here. 1 to infinity of each term. And this is a hassle to learn how to write, because we'll have this, x minus x to the third over 3 factorial plus x to the fifth or 5 factorial, ... And we have to say, all right, summation from, I think I'll use n equals 1 to infinity of How about -1 to the n? No, that doesn't work. How about n plus 1 squared third? Oh, that gives me the positive negative. Okay, good. Got that part. And then it's x to the, let's try 2n plus 1. So 2 plus 1, no, that didn't work. Let's try, and this is the hard part. And people get very frustrated, but you look for patterns, you see it. 2 minus 1 is 1, great. Plug in 2, because remember, these are just like series sequences. 1, 2, 3, first term, second term, third term. Yes, I could call this a 0, but it's usually easier to call it a 1. So when I put in 2, I get 4 minus 1, I go to the third, cool. And then actually, hey, I'm done. It's over 2n minus 1 factorial. That's hard. That is not easy. So yeah, we're gonna do this. All right. So what does it mean if a series converges or diverges? And you're saying, we know this, we did this. Yeah, we did it for sequences. All right. So converges, we say it gets closer and closer to a number, like the 2 up top. Diverges, it doesn't converge. So here is a series, but when it was a sequence, we just kind of said, oh, it goes 1, -1, 1. We said, oh, it diverges. Yeah, but now we're adding them up. So let's see what's going on. Partial sums. First 2, we get 0. First 3, we get 1. Then it goes back to 0. Then it goes to 1. Does it get closer and closer to a number? No, it diverges. The series diverges. Sometimes I think it's a mistake to teach sequences before series because people start projecting one concept onto another, but it's better, trust me. At least you got a taste of it. So, all right, let's do the partial sums. Here's an AP question straight off. Okay, this is a 0.3. This is 0.33. This is 0.333. And look at that, we got the nth term. Oh, all right, it looks like this is getting towards 1/3. Keep adding 3's on forever. All right, well, this is a geometric series. And I don't believe I proved this. You're just going to have to take my word for it. Where the first term, A1 equals 0.3, 3/10. And then what are we multiplying by to get here to here? Well, R equals 1/10, 0.1. So what does it add up to? The sum of an infinite series is A1, 1 minus R. Holy mackerel, lock this down. Lock this down. You're gonna need it. It's gonna save you so much time and aggravation. 0.3 divided by 1 minus 1/10 is, actually I'll go with the tenths, 3/10 over, let's make this 10 over 10, 9/10, cancel, 3 over 9 cancels to 1/3. I cannot tell you how many times that's bailed me out of a problem when I got lost. So be prepared. So we're going to ask this question. How do we know if an infinite series converges? It's a big question. It's something we will spend a lot of time on. All right. Number 1. This has to be the case. Okay. You must have at least the fact that as we go to infinity, the terms get closer and closer to 0. Now, back the page. Right, closer and closer to 0. But this one's closer and closer to 0. How come it diverges? I didn't say if it goes to infinity, it would definitely converge. I said at least before we say, is this converge? You know what? The first thing we're going to check is, does it get closer and closer to 0? If not, or This one down here, these terms aren't getting closer and closer to zero. They're just going up, down, up, down, up, down. So this is going to diverge right away. We did partial sums, shows it's going to diverge, but we could have said the limit as we go to infinity of each of the terms is not zero. So this is going to diverge anyway. So you can see how this is a big sticky ball of wax. It's kind of hard to figure out where to stick our hands into it. So we're just doing the best we can from whatever we can. So I've just shown you a geometric series earlier. Now we got to be really careful here because I was not complete. I said, oh yeah, sum is the first term. And sometimes I couldn't put a naught here. I'm going to keep it as 1 over 1 minus r. Well, yeah, that's if r is between -1 and 1. I thought you said r. Yeah, this is the same thing as saying -1 less than r less than 1. Here I am with the third or fourth major concept I'm throwing at you. Just take a second and think about it. Let's say r was 2. Let's say r was 2. And we pick any term we want. Let's start with 1. 2, 4, 8. We can't add it all up. That's why that definition exists. If it's 2, it gets bigger and bigger and bigger. If it's -2, it would oscillate all over the place. The terms aren't going to 0, so there's no way I can do this. The way a geometric series goes to 0 is if r is less than 1, 0.9, 0.1, -0.2, these terms get smaller and smaller and smaller. We can add them up with this little formula. Please lock this down. And whenever you see an AP question that says, what is the sum of this series? It's a geometric series. It's the only one we know how to add up. Unless it's one of our special Maclaurin-Taylor series, but no, that's not going to happen. You have to go, oh, let's go down here. Are we in a geometric series? Well, we're multiplying by 1/2 every time. We write this out, we get, plug in 1, 3. This is a series, so it's not a comma, plus 1, 2, 3/2, plus 3/4, ... It's getting closer and closer to 0. The r value is 1/2. Okay, yeah, I can do this. So the sum as we go to infinity is 3 over 1 minus 1/2 is 6. If you want to do partial sums and see what happens here, it's not a bad idea. So converges. Now be careful here. Read the full question. Did I ask for the sum? Yeah, I said it converges and find the sum. So yeah, it converges and 6. Let's do one that diverges just for the fun of it. Multiplying here by pi. R is pi. Bigger and bigger and bigger. So done, diverges. Can't add it up. And a lot of people are like, oh, I love those diverges. I don't have to do any work. It just diverges. Yeah, well, here, and I'm going to start going a little bit quicker, multiplying by -1/2. So the sum is 1 over 1 minus -1/2. That's 3/2, it's 2/3. And they ask the question, so answer the question. Converge. Well, if I say it adds up, doesn't that imply? No, yeah, write it out. Be clear. Here it's like, well, what's the first term? I don't know. Put in 0, we get 1. So A1 equals 1. Sum of infinity is 1 over 1 minus 3/5. That's 1 over 5 over 5, 2/5, which is 5/2. That just answered 1 or 2 AP questions on every test. Hey, talk to me about this series. Does it converge? What does it converge to? Oh, it's geometric, and off we go. So I just said, if R is, we're going to call it X. Why? Just to piss you off. All right, just deal with it. If X is less than 1, we get this. Well, wait a minute. What do you mean geometric? How do I even know this is geometric? What am I multiplying to get from here to here? Times X times X. Oh yeah, it is geometric. Oh, and we just proved that the R has to be, yeah, okay, so all right, that makes sense. This is A1. Might not always be 1. To be aware. All right, but that's it. It's just a geometric where we change it to x. Usually that's done like the 5th lesson in Algebra 2. So yeah, notice how quickly we're going. Boy, boy, oh boy. Like I said earlier, lock that down. Okay. Oh, hey, check it out. Maybe there's a coefficient out front. It's not just 1. Maybe the first term is some value. Oh, okay. And then we're just giving you a definition. Kind of use geometric to kind of come in the side door for what a power series is. Well, power series means a summation. Oh no, they changed it to 0. Why would they do that? Not a big deal. Sometimes it just makes it easier to write x to the first, x to the second, 0th term, first term, second term. It's not a big deal. Don't worry about it. What the hell is that centered at 0 means? Well, I can't explain that until I show you this down here. This is a powered series centered at x equals a. Why would we do that? Yeah, that's a big question. I'll show you later. Instead of x, first, second, third, we have x minus a because it's centered there. When I plug in a, I get a 0. It zeroes out everything except for the first term. Okay, so that just means it's centered somewhere else. Sure, whatever you say. We'll show you how that centered works when we get to certain Maclaurin and Taylor series. So we got an nth term, and the number a is the center. Everything kind of fans out from there. Sure, Mr. T, I don't know what the hell you're talking about, but that's fine. Well, wait a minute. What if it was geometric? If, that's a big word, geometric, then the summation would be first term's just that weird C naught. 1 minus, what are we multiplying by every time? Well, we're multiplying by an x minus a, x minus a. Which you say, okay. I don't know what the hell's going on, but okay. Whatever you say. Yeah, it makes sense after you do it a few 100,000 times. So we already said this. Geometric series is a power series. Power series aren't. Geometric series can be a power series. It's not always, but power series is not always a geometric series. It's just an easy one to work with. So again, we're coming in sideways. This is centered at x equals 0 because there's no x minus thing here. And it converges when absolute value of x is less than 1. This freaked me out the first time because I'm like, yeah, I understand this. Between -1 and 1. What the hell does this mean? These are the same thing. If it helps you write it as this is the way we're going to do it going forward. It's kind of slick. Yeah, whatever. All right. I would pause the tape right now and just take a deep breath because here we go. That little definition means off we go. Before we answer these questions, for any interval of convergence, we're going to try, but we have a whole lesson on this. So if I say, don't worry about it right now, trust me on that one. It might be like, again, it's a big sticky ball of wax. We can understand this, not that hard. Right? This means that if I know it adds up to 1 over 1 minus x, well, x now is what? Oh, so to get this, I have to go 1 over 1 minus negative x. Oh, okay, I can use that to figure out, find the power series. That's what we're trying to do. That means first term is 1, but we multiply by negative x minus x. Well, wait a minute, you said we're multiplying by negative x. Yeah, the negative gives me a positive. Plus ... Sum n equals 1. I thought you were using 0 now. It doesn't matter what we use. All right. And actually, that is wrong. I found a mistake in my notes. I think I'll go with 0. You can go with 1 and then just change it to n minus 1, n plus 1, whatever. N equals 0 to infinity, x to the n. No, negative x to the n. Anything to the 0 is 1. The next term I put in 1, I get that squared. Yeah, okay, that worked. Constantly checking my work, constantly making sure I did it right. Apparently my notes I did not. Okay, try again for x over 1 plus x. Oh, we never did interval of convergence up here. Now it would be absolute value of negative x is less than 1, which is the same as absolute value of x is less than 1. Don't get hung up on that. Like I said, we're going to come back later. Okay, that was weird. All right, what's our original value here? Well, what do you want to call it? A naught, C naught? Who cares? I'll call it A naught. Yeah, but the previous page had C. Don't worry about it. X, and then it's that R value is negative X, because that's negative, negative. We've seen that trick before. So the series would be, the first term would be X, and then we would say times negative X. So the original X times negative X, and then the next one would be X times negative X squared, X times negative X to the third, and off we go. Yeah, that's it. Let's put it together. Minus x squared plus negative's gone, x to the third. Oh, I'm starting to see how this works. Yeah, don't get cocky. You can get away from you really fast. How about we go n equals 1. And I'm going to show you something. I did not do it up here. I like to pull that alternating aspect out. Positive, negative, and that alternating aspect is very important. Just going to pull it out. Now, I'm going to call this n plus 1. I could actually call it n minus 1. It doesn't really matter. And that freaks people out that we can write different solutions, but it's not the end of the world. And then I'm going to call it x to the n. And you know what? I don't like that. Okay, fine. Be a jerk. 0 to the infinity, and we'll say it's negative 1 to the n, and x to the n plus 1. Notice it's outside, notice it's inside. It doesn't matter for this. Does that work? Plug in 0, I get x. Oh, yeah, it works. So every time you write this, you have to sit down and say, did that make sense? Now, I avoided this in the previous problem. So let's do it here. What's up that interval of convergence? Since my r is negative x, I should do this. Negative 1 is less than negative x is less than 1. Let's divide by negative 1. Don't forget it flips the sign. So we get 1 is greater than x is greater than, well, you can't write that. You have to put it in the right order. So there's your interval of convergence. Meaning, and this series is fine. I can put in any number I want. But if it's going to converge, the x has to be greater than negative 1, less than 1. This is where people say, I've had it, I quit. Don't. We're going to get there. We're going to practice like crazy, and we're going to get there. Here are, I think I'll call it C naught this time, is 1. And our value is negative 2x. No, it isn't. It's positive 2x. 1 minus is the typical. It's positive 2x. All right, cool. So 1 plus 2x, because times 2x, plus 2x times 2x, plus 2x times 2x times 2x. 1 plus 2x plus 4x squared plus 8x to the third. Sum from, I think I'll use 0 this time. 2x to the n. So we get, this works. Plug in 0, we get 1. Plug in a 1, we get 2x, so on. Yeah, I don't like that. I kind of like breaking out the 2. 2 to the n, x to the n. And you might say, well, this is more elegant. It's cleaner. Yeah, but I like breaking out the pieces so I can make sense of it. Holy mackerel, what about that interval convergence thing? Negative 1 less than 2x less than 1. What happened to the absolute value thing? Well, I can write it either way. I'm purposely bouncing around to keep people on their toes. Divide everything by that. And here you have to say, you know what, this only converges. It's a perfectly fine series, but it only converges between negative 1 and 1/2. All right. Now I'm just messing with you. 1 over x, 1 over 1 minus. How do I get that to be 1 over x? How about 1 minus x? 1 minus 1 vanishes, negative becomes positive x. Cool. All right. First term is, I can call it the naught term if I want. Yeah, I think I'll call it the naught term. First term is, the top of the fraction is 1, and our r value is 1 minus x. So off we go. 1 plus multiplied by 1 minus x plus 1 minus x squared plus 1 minus x to the third. All right, how the heck do we write that? Well, sum n equals 0 to infinity, 1 minus x to the n. Plug in 0, plug in 1, plug in 2. Yeah, okay, that works. Oh, for goodness sakes, but what about that r thing? All right, I'll use absolute value just to bother you. 1 minus x less than 1, which always becomes -1 is less than 1 minus x less than 1. Subtract 1, we get -2 less than -x less than 0. Divide by negative and everything flips around, we get 0 less than x less than 2. Hey, where's it centered now? It's centered at x equals 1. You check that out. This would be like, oh yeah, that's, it's starting to make a little sense. Boy, I think I need a lot of practice though. Yeah, that's an understatement. Okay, here we go. Almost there, I promise. The pain will be over soon. So, how can we do calculus to this? Everything up to this point is really nasty algebra. Well, we know this one. This is 1 plus x squared plus x to the third, dot, dot, dot. Well, what if I took the derivative of this? Well, let's see, that's 1 minus x to the negative first. So it's like taking the derivative of 1 minus x to the negative first, and the derivative of the other side. So negative out front, negative 1 minus x to the negative second, chain rule, and we would get derivative by 1 plus 2x plus 3x squared plus dot, dot, dot. So this becomes 1 over 1 minus x squared equals 1 plus 2x plus 3x squared plus confusing, sum n equals, I'm going to go with 1 to infinity. N times x to the n minus 1. And I could write this with a 0 some other way, but let's check it out. 1, 2, 3. Yeah, that works. 1 gone. 2. Yep, that works. And what about the interval of convergence? Like I said, later, don't get hung up on it. But notice how we use some calculus. This is not a geometric series. It doesn't multiply up by a constant. So we started with a geometric and we messed with it. We're so weird. What's up? I was looking for that like an hour and a half ago. Otherwise, I wouldn't be talking to my computer at this point now. How are you, Miss Pagano? Oh, I'm just having a delightful day. You know how it goes. I can't complain. Things are fine. Printer didn't want to work this morning, and whatever else is new. And I'm psycho because I'm redoing all my videos because students ask me to. They made the point that a lot. That's true. Yeah, exactly. Although I heard you use that in like 5 seconds. Not worth it. It's just not worth it. Yeah, boy, it's good that we no. All right, I got another. No, I got like 90 seconds here. So then you can be loud and talk. And then I'll put my mask back on.